Heat of reaction. In thermodynamics, a reaction can do two things: release heat or consume heat. A reaction that releases heat is exothermic, but a reaction that absorbs heat or energy is endothermic. The value of delta H, or the heat of reaction, is positive for an endothermic reaction and negative for an exothermic reaction. It is also important to understand that reactions can happen in the forward direction, from A to B, or in the inverse direction, from B to A. For example, if reaction A to B has delta H of positive 7 kilojoules, it's an endothermic reaction. The inverse reaction, B to A, is therefore exothermic, and its enthalpy of reaction is negative 7 kilojoules. Also, when talking about heat of reaction, it's important to understand the concept of HESS'S law. This law says that if a reaction is composed of other intermediate reactions, the heat that it releases or absorbs will be equal to the sum of all the heats released or absorbed by each intermediate reaction. For example, delta H for the reaction A to C is equal to the delta H for A to B plus the delta H for B to C. To solve this problem, we first need to look at each reaction individually. Delta H for the reaction D to A is simply the inverse of delta H for A to D, so we need to find this value first. It's easiest to solve this problem by identifying the heat of each reaction with the help of a simple diagram. We know that according to HESS'S law, the heat of the total reaction will be equal to the heats of A to B, B to C, and C to D. Starting with the reaction from A to B, we know that this reaction has a delta H of positive 4 kilojoules. Then we look at the reaction from C to B. We have this value for the reaction, so the value for B to C is simply the inverse of this value. So the negative 9 kilojoules becomes positive 9 kilojoules. Finally, we know the enthalpy for C to D, so we write the negative 2 kilojoules. Now we look for the enthalpy of the reaction from A to D. Like we said earlier, this will be equal to the sum of each reaction from A to B, B to C, and C to D. We get the addition of 4 kilojoules plus 9 kilojoules plus negative 2 kilojoules, getting a total of 11 kilojoules. However, we want the enthalpy from D to A, not A to D. All we need to do here is change the sign in front of the 11 kilojoules to get negative 11 kilojoules for the reaction from D to A.